In this lecture, we'll discuss the one-way analysis of variance, or one-way ANOVA as it's also known, or just simply the ANOVA. And we're going to do a couple examples together in SPSS, and I'll show you not only how to apply this methodology, but also how to report your results in APA format. We'll also be covering post-hoc analysis through the utilization of TukeyHSD, and I'll show you how to report that post-hoc methodology in APA format as well. So we're just going to do a quick refresher. And again, I'm going to assume that you at least have some sort of cursory understanding of this methodology and when it's appropriate to apply. And as always, all code related to this video's exercises can be found in the video description below, along with the associated data file, which is in CSV format. So ANOVA is used to compare the variances of various sample groups against one another. In many ways, it's similar to a t-test. However, ANOVA allows for multiple group comparisons. This differs from the t-test, which at most only allows for one single group to be compared to another single group. So here is our example, our one-way analysis of variance example. A chef wants to test if patrons prefer a soup, which he prepares based on salt content. He prepares a limited experiment in which he creates 3 types of soup: soup with a low amount of salt, soup with a high amount of salt, and soup with a medium amount of salt. He then serves this soup to his customers and asks them to rate their satisfaction on a scale from 1 to 8. We're going to assume an alpha value of 0.05, and something important to remember when it comes to one-way ANOVA is one observational series could be larger than the others. They don't need to be of equal length. So in this case, we have more observations for medium than we have of low and high. However, we could have, say, 6 observations for high, 2 for medium, 4 for low. It doesn't matter. They can be of unequal length. The hypothesis for this particular analysis that we're going to perform is that all of the means are equal as far as rating is concerned, as it relates to soup type, soup being our grouping variable, and the alternative is not all means are equal. So let's go ahead and apply the one-way ANOVA methodology in SPSS. Let me get the appropriate data set up. Here we go. So we're going to go to Analyze, then we're going to go to Compare Means, and we're going to select one-way ANOVA. Let me get these out of here. I was just playing around with it before I began shooting this video. So our dependent variable is going to be our rating variable. This contains the numerical observations. And our factor variable is the category variable. Now, as you can see here, we have low salt, medium salt, and high salt. And when you get the data from the video description, this data is going to be downloaded in CSV format. As such, you have to put the observation labels on yourself for low salt, medium salt, and high salt for this particular analysis methodology to work. So I'm going to enable some post-hoc analysis by clicking Tukey for equal variances assumed. I'm just going to click this box right here. That's it. Click Continue, and then click OK. Now let me get our output. Here is our output. Here is the output as it relates to the initial ANOVA methodology application. And here is the TukeyHSD Post-Hoc application. But what does this mean? Well, let's go to our slides and make that determination. So here is our output as it relates to just the ANOVA itself. We can see that there is not a significant effect of salt content on the customer rating of soups at the p less than 0.05 level for the 3 conditions. Those being degrees of freedom for the between groups, the within groups. Here is where we place our f value, rounding to 2 significant figures, and our significance value, our p-value, goes here also to 2 significant figures. And this is how you would write these findings out. And as you can see, our p-value is 0.82, which is far high and above our assumed alpha value of 0.05, so we will not reject the null hypothesis, and that there is why there was not a significant effect on salt content, which means because there was not a significant impact, because our p-value is greater than 0.05, we don't even need to look at the Tukey's HSD post-hoc analysis. You can view it if you like, but it's not applicable as it relates to this particular methodology application. But I did create this very large set here, also in the video description, which we're going to also analyze, and we're going to determine whether or not there's a significant differentiation between these various groups here. So we have group A, group B, group C, and group D. I don't have a word problem which corresponds with this particular bit of data, so you're just going to have to use your imagination as to what these groups are actually representing. But in any event, for this particular ANOVA that we're doing, we're assuming that the mean for each particular group, for group A, group B, group C, and group D, the null hypothesis is that all these means are equal. And the alternative is that not all the means are equal. So all the means are equal, or not all the means are equal. And this differs from a t-test in that if it were a t-test, we would have to do A compared to B, that would be one test, A compared to C, that being another test, A compared to D, that would be another test, B to C, C to D, and then B to D. And each one of those would be one t-test. So 1, 2, 3, 4, 5, 6 separate t-tests, or just one ANOVA test. So we're going to go with the ANOVA test. So let's do that now. Let me get the appropriate data. Here it is. And this is how it's going to look in the CSV. You're going to have to put the labels on the observations. 1 is A, 2 is B, 3 is C, and 4 is D. So go ahead and get those applied. Now let's run the appropriate analysis. We're going to use a one-way ANOVA. So analyze. We're going to go to compare means. We're going to go again to one-way ANOVA. And we already have placed, I'll do it again, we've placed rating, which is our numerical variable. We're going to place that in our dependent list. And our categorical variable group, we're going to put that over here. So we're grouping the rating by these categories. Category A, B, C, D, and so on. Now again, we want to make sure post-hoc is enabled. We want to make sure this box Tukey has been selected. And I should also mention that we have some other options here if you'd like to utilize them. And probably the most important amongst such is the confidence interval. You can change this to whatever is appropriate if you're using a alpha value, which is not 0.05, ours is, so our confidence interval is 0.95. Once everything has been appropriately entered, we're going to click OK. And now let's go back to our output. Here it is. So here is our output as it relates to our ANOVA. And then here is the output as it relates to Tukey's HSD. And in this case, because our findings were significant, we're going to go and assess the Tukey's HSD output findings. And we'll need that for reporting our results in APA format. Now, something else we're going to have to do as it relates to this example is we're going to need some additional information for our APA output formatting. What we're going to need to do is we have to go to Analyze. We're going to go, again, to Compare Means, and we're going to go to Means itself. And we need rating to be in our dependent list. And our layer 1 of 1 is going to be the variable which we're categorizing by, which is group. Make sure for options that we have mean, number of cases, and standard deviation selected. Most importantly, mean and standard deviation. Once those have been put in the cell statistics box on the right, click Continue, and then click OK. And I'll show you why this is important in a moment, but here is what it resembles in our output for SPSS. So now let's go back to our slides and tie this all together. So here was our initial output for the one-way ANOVA methodology application. We have the degrees of freedom for between groups and within groups. We have the F value, and we have our significance, which is below our assumed alpha of 0.05. So we'll reject the null hypothesis in that all of the means for each group, group A, group B, group C, and group D, they're not equal. Now we're going to look at our Tukey's HSD output, and we're only interested in instances in which the significance is less than 0.05. Less than 0.05, okay? Not less than or equal to, less than 0.05. And what this is doing is it's comparing the differentiation of groups. So this is group A compared to group B, group A compared to group C, and group A compared to group D. Group B compared to group A, B to C, and B to D. And you can see this makes sense when we look at B to D. It has the same significance rating, standard error, and mean difference rating as it does in D to B. See, same rating, same values in each instance. So we can see that the means, as far as mean differentiation is concerned, when applying the Tukey's HSD, there's a significant differentiation of mean for B as compared to D. So for categorical group B, the mean has a significant differentiation as compared to group D. So how do we report all of this? Well, first we have to report just the ANOVA findings. We're going to report that there was a significant effect of group designation on the reported scores at the p less than 0.05 level. P less than 0.05 because our alpha is equal to 0.05. For the four conditions, here's our between groups, here's our within groups, here's our F statistics value, again, to two significant figures, and here's our significance to two significant figures, less than 0.05. But now, because this is less than 0.05, because we reject the null hypothesis, we now have to report our Tukey's HSD findings. And this is going to demonstrate that there was, and I'm just going to read this off, post-hoc comparisons using a Tukey's HSD test indicated that the mean response score for the group B category, and here's the mean for group B's category, so all the values for group B as they were in our data set, if we were to add all those values together and take the average, this is the mean, and this is the standard deviation for all of those values. For group B, it's significantly different than group D. Here's the mean for all the values in the group D category. There's 15 observations. And the standard deviation for that, here it is, group D, 6.47. Standard deviation, we round to 0.160. We see that there was a significant differentiation there, meaning that the differentiation as it pertains to our initial findings as it relates to the application of the one-way ANOVA, the main differentiation as it relates to those findings was between groups B and group D. Now, I do want to mention prior to ending this video that there are instances in which you will have significant findings as it relates to your application of the one-way ANOVA, but in then running a Tukey's HSD, you may find, and again, this is rare, but it does occur, you might find an instance in which every significance score as it relates to the comparison of groups is above 0.05. So let's say instead of 0.38, this was 0.58, in which case not a single one of these group comparisons was significant. And if that were the case, we would report our initial findings as it relates to the ANOVA, and then we would state that post-hoc analysis using a Tukey's HSD test revealed no significant pairwise differences between the groups, all p-values greater than 0.05. And this is what we do when the Tukey's HSD post-hoc analysis reveals no significance between groups. So again, Tukey's HSD is something you utilize when you find a p-value, which is less than your assumed alpha value for your one-way ANOVA. And what it's going to demonstrate is to where the differentiation was between groups. There's different post-hoc methodologies that can be applied, but Tukey's HSD is one of the most commonly applied and one of the most commonly reported. So you can't go wrong with it. So that's where we're going to end today. If you enjoyed this video, please consider liking and subscribing. If you have any questions, maybe leave a comment so we can help one another out. We're trying to get the message out to as many users as possible. So best of luck in your research, and thanks for stopping by. And until next time, take care.